Now in this one we have three resistors that are in parallel. We know what those resistance values are, and then we know some of the voltages. We know the voltage across the battery, and then we know the current across the second light bulb or the second resistor. So remember that whenever resistors are in parallel, we're going to inverse add those. 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3. So I'm going to have 1 over RT equals 1 over 5 plus 1 over 15 plus 1 over 0.2. And remember, to do that, we're going to use the inverse button on our calculator, which is this inverse x to the negative 1. So I'm going to say 5 inverse plus 15 inverse plus 0.2 inverse. I'm going to enter, and then I need to flip it one last time because it's not 1 over RT, it's RT. So I'm going to inverse that one more time, and I get a total resistance of 0.1899. Now remember, in a parallel circuit, the total resistance has to be smaller than the smallest resistor. So notice that even though these are pretty big, this one's really small, which means my total resistance was less than that one, 0.1899 ohms. Now I can start filling across the table too. I could take V equals IR, which is Ohm's law, remember, and I'm going to take and multiply these two, so 0.2 times 15, and that gives me a value of 3. I can look then at a parallel circuit, and what do I know about the voltages or the currents? And remember that in a parallel circuit we know PVC, parallel voltage constant, so V total equals V1 equals V2, and notice that we even started to prove that already. This is also 3, this is also 3. All four of these are 3 volts. Now I can easily fill across on my table, right? I can take this voltage, 3 divided by 0.2, so 3 divided by 0.2, and I get 0.6 over here. I can take this 3 divided by 5, 3 divided by 5, and I have 0.6. And then I can take this 3 divided by 0.1899. So I have 3 divided by 0.1899, and that gives me 15.8. Now remember, we can add those up for currents, and that should give us a total current that is the same up here, because remember, in a series circuit, our currents add up, I1 plus I2 plus I3. And you'll notice that something's wrong because they don't add up to be that. So I have 0.6 plus 0.2 plus 0.6 does not give me 15.8, which means that I messed up somewhere. And that's got to be probably this guy. If I take 3 divided by 0.2, I don't get 0.6, I get 15. Now when I do add those up, 15 plus 0.2 plus 0.6, I do get the 15.8. And that's how we would fill in a table for a simple parallel circuit.